Okay, but I can't see my chat and all those things. No, no, you don't get it. I'm not. Okay, all right, bye. All right, students. Apparently, I'm live now. I've been told so. I'm not able to see the chats. I'm not able to see the video of my own session. Probably because I'm not used to this YouTube functioning. So, guys, please pardon me if you feel that your experience is not as good as it is with other teachers. So with this, I'll start the discussion of essay paper. We have discussed some questions before also on the day of the examination. Probably, yeah, on the day of the examination itself, we discussed essay paper, some questions of essay paper. In fact, majority questions of the essay paper. Today, we'll be discussing the entire paper. So now that the official paper is out, we'll be discussing each and every question. For those of you who are not aware, my name is Vikas Agarwal and I teach physics at Vedantu. So, let's get started already. This subscribe thing, I hope you all have done that already. So let's just move on. So this is the part 1 of the physics paper, and the first question says, now this question we received on the day of the paper also from our students, and we discussed this earlier also. We'll do it right now again. So this question is based on projectile. Just a minute, I think I moved on to the next question. Yeah, this question is based on projectile, and this question says that a mouse jumps off from the 15th floor of a high-rise building. So there is a building in which there are 15 floors and each floor has a height of 3 meter, which means that the total height of the building is 45 meter, and the mouse has jumped off this building and the mouse eventually lands 12 meters away from the building. So this is what the question says, and now we are told to find out the speed with which this mouse has jumped. So it's a very simple case of a horizontally thrown projectile. And I think you all have learned this formula. You should be aware of this formula. So in this case, the expression for range is V0 root of 2h by g, where V0 is the speed with which the projectile was thrown horizontally. This is the height and this is the horizontal range. So in place of range, I'll put 12. V0 is what we want to calculate. Then in place of h, we will have 45, and in place of g, we can put 10. The value of g is not mentioned in the question, but we can take it as 9.8, we can take it as 10. I can see that taking it as 10 will make the calculation easy for me, so I'll do that way. So it will become V0 into root of 9, which is 3. So from here we will get V0 equal to 4 meter per second. So a straightforward simple question. Alright, expecting many of you to get this one correct. Let's move to the next question now. Yep. So next question says that there are two wires of same material and their ratio of their radii is 2:1. So these wires are stretched by equal force, and we have to tell the ratio of stress produced in them. Again, a very simple question. You just need to know the definition of stress. How do we define stress? So stress is force upon area. Alright, now that we are exerting the same amount of force on both the rods, alright, so we can say that sigma 1 by sigma 2 will be equal to A2 by A1, which will be equal to pi R2 square by pi R1 square, which means R2 by R1 square. Check this. The question says there are two wires of same material, so material is same, having the ratio 2:1. So the ratio of the radii is given to us as 2:1. Okay, so I'll be substituting 1 upon 2 here, because this 2:1 means that 2 stands for the first radius, for the radius of the first wire, and 1 stands for the radius of the second wire. So we'll be using 1 by 2. So square of this, so 1 by 4 is what we are going to get. So in the options we do have 1 by 4, so option A will be the correct one. So again, straightforward question, nothing fussy about this question, no complications, not mathematically, not conceptually. So simple question, this one. Now let's have a look at the next question. Now this is the question that we did not discuss, which we did not get from our students on the day of the examination. So this is a new question for us. Now let's have a look at it. It says that a submarine has a window of so and so on its ceiling, and it is a depth of 100 meter below the sea level in a sea. So there is a submarine. If the pressure inside the submarine is maintained at the sea level atmosphere pressure, then the force acting on the window is. So guys, what we have to understand in this question, what we are trying to do is something like this. Let's say, let's consider a circular window. Okay, that is what we see when we see submarines in movies and all. I doubt that many of you would have seen a submarine in real life. I haven't seen one. So let's say there is a circular glass, all right, and this is the boundary of the submarine. Okay, it need not be like the window can be a vertical window also. So inside there is pressure, which is atmospheric pressure, like inside the submarine. Let's say this is the inside of submarine where the sailors and the commanders of the submarine are present, and this is the sea side, and this is water present here. Okay, and this height is given to be 100 meter. Okay, this height is given to be 100 meter. So the pressure that liquid exerts from here, this will be P naught plus rho gh. P naught pressure is being exerted from the inside also. This is due to the air that was trapped inside the submarine. When the submarine was on the shore, when it was above the surface of sea, at that time when the doors were shut, at that time the pressure inside the submarine was atmospheric pressure, so that pressure will still be maintained. So now if we have to calculate the force acting on this glass, it is basically due to the difference of these two forces or these two pressures. So what we are looking to calculate is rho gh into the area of this. So instead of rho, we can substitute the value of I think it's given in the question. This density is given in the question, so we can put 1030. I have multiplied this 10 raised to power 3 with the given number. Then g, we can consider it to be 10. I think it is given in the question also, so we don't have to make any assumptions. We can just put the value there. And then height, so height would be 100 meter, and then cross sectional area, so this area is 900 centimeter square. So let's convert it into meter square, because all other measurements are in SI units. So let's convert the area also in meter square. So this is what we are getting. Once we finish this calculation, we'll get the answer. Let's try to estimate what we are going to get. So as far as this 10 raised to power minus 4 is concerned, let's cancel out 4 zeros. So we have lost 4 zeros. Now what do we have? 9 multiplied by 103. So that would be 927 sort of, 927. And then how many zeros we have? I guess we have 2 zeros to add. So this is the answer. Now the closest value from among the given values is, I guess we can write this as 0.93 into 10 raised to power 5. Alright, so this option stands the correct one. Alright, again, I guess the given situation will take a minute or so for the students to comprehend what is going on. Once you realize what you need to do, the question is again looks like a straightforward one. Alright guys, let's move to the next question now. Now this is a good question. This is a tricky question. This is something that I guess students would have struggled with. So let's try to understand what is happening in this question. In this question, it says that a spacecraft is moving with a speed u relative to the Earth. Alright, so guys, yeah, we have to understand here that Earth may be somewhere here. Like, okay, this is some activity which is going on in space, and Earth is a separate, separate planet. So a spacecraft which is moving with a speed u relative to the Earth. Alright, so basically the observer is sitting on Earth, and that observer observes this spacecraft to be moving with speed u, okay, in the x direction, enters the gravitational field of a much more massive planet. Now what is the significance of this massive word here? So this spacecraft was traveling from far away. Alright, I have drawn this a little farther away to emphasize that it is coming from a very far off distance. So we can imagine that probably the gravitational force of this massive planet becomes significant somewhere around here. We can just say the question wants us to believe like that only. So this was coming from infinity, which basically means that it did not belong to the gravitational field of this massive planet. It was it was coming from here, and then since this planet is massive, though this planet will experience an attractive force from this spacecraft, but the motion of this planet will remain unaffected, largely unaffected. So for an observer on Earth, what will happen? An observer on Earth will say that as this spacecraft is approaching the planet, the speed is increasing. Alright, or rather we can just say the speed is changing, though it will increase. So the speed is changing, but the speed of this massive planet will not change. It will continue to be the same. Okay, for an observer on Earth, this massive planet will continue to move with 3u, whereas this object will start accelerating. Okay, now, you know, if you can relate to this situation, if you can recall, this is something that happened with our Chandrayaan. Okay, something similar. You know, Chandrayaan came from far away, and then because of the gravitational pull of the moon, it started accelerating while the moon continued its journey around the Earth unaffected, and then eventually the Chandrayaan crashed on the moon. Here, what we are saying is that this spacecraft doesn't crash, but because of the gravitational attraction of this planet, it turns and goes away, and we want to calculate the speed when it does so. When finally it goes away, we want to know with what speed it goes away. All right. So this is the question. Now let's say, how can we solve this question? To solve this question, I'm going to ask you some questions. You try to answer those questions, and the final solution of this problem will be hidden within those questions only. So my first question to you is, given that this planet continued to move with a speed of 3u throughout the discussion, can I call this planet as an inertial frame? Think about this. We are saying that this planet continued to move with a speed of 3u. So can I call this as an inertial frame? And if I can call, which we can, I guess. All right, it is correct to call this as an inertial frame. So we can solve this problem by going into the frame of the planet also. So let's do one thing. Let's make another figure. Let me change the color. All right, I'll make another figure, this time with respect to the planet. So with respect to the planet, let's say if this is the planet, with respect to the planet, what will be the speed of the planet? 0. Anything, with respect to itself, any observer with respect to himself is always at rest. So this planet is at rest. Now, as far as the speed of this spacecraft is concerned, when it was far away, that speed as seen from the planet will be 4u. Think about this. It was coming from far away. The planet itself was traveling with 3u. So a person sitting on the planet will say that the spacecraft was coming with a speed of 4u. So this spacecraft came with a speed of 4u. In this frame, it is at rest. So any individual who belongs to this planet, who is a resident or who lives on this planet, that person will say that there is a body, there is a something coming from space, and it is coming with a speed of 4u, and ultimately it turns and goes away. So to conserve energy, see, this man is not moving at all. So to take care of energy conservation, when this spacecraft goes away, it has to go away with a speed of 4u, but this is with respect to the planet. But this is with respect to the massive planet. So any person standing on this massive planet will say that a spacecraft was coming to me with a speed of 4u, and then it encircles the planet, and then it goes away. And when it goes away, when it finally reaches far away, the speed has got to be the same with which it was coming. So this speed will be 4u with respect to the planet. Now, if we use our knowledge of relative motion, and if we try to convert this figure into a figure that is seen from Earth. So with respect to Earth, what we are going to say, with respect to Earth, this is moving with 3u, and the speed of this spacecraft with respect to the planet has to be 4u. So that can happen when v is 7u. Check this. If I choose v as 7u, then the relative speed of the spacecraft with respect to the planet comes out to be 4u, which we wanted. Alright, so eventually now I am in the position to say that as seen from the Earth, the speed of this aircraft will be 7u. So 7u, the option, it will be your answer. Alright. So guys, while explaining, it may appear that it is a long question, it is a lengthy question, it consumed a lot of time, but if you are able to think all of this on your own, it takes about 1 minute to address this question. Like if you can think of this, if the idea clicks to you that since the planet is moving with a constant speed throughout, we can treat the planet as an inertial frame of reference, and hence we can solve this problem very easily. Now let's move to the next question. Alright. Guys, please pardon me, I'm not able to see your chats, largely because of my handicap with dealing with this YouTube sessions and all those things. So even if you're writing something, I'm not able to see that. So guys, I understand that that may have hampered your session a bit. Please bear with me. Alright, now the question says Earth's magnetic field was flipped by 180 degree a million years ago. This flip was relatively rapid, and so guys, some information is given to us, but eventually if I try to understand what is expected of me in this question, eventually we have been given that something changed its direction. Alright, that something was Earth's magnetic field, but that is not of any concern. So something changed its direction by 180 degree, and it did so in this much amount of time. Alright, so basically what I understand is that an angular displacement is given to me. This is 180 degree, which we can also say as pi radian. So an angular displacement is given to us, and then we are also told that the average change in orientation per year during the flip was closest to. So average change in orientation per year. So basically the angle changed per year. So that is angular velocity in radian per year. Actually, see, when I see the options, I see that the options are given in seconds. So I guess instead of going into the radian, we should stick to the degree notation. In fact, we should convert degree to minutes and minutes to seconds. So what we are looking at is this: 180 degrees means 180 into 60 minutes, means 180 into 60 into 60 seconds divided by the given time span, which is 10 raised to power 5 years. Alright, so this is seconds per year. This is what we are getting. Alright, and this is what has been asked: change in orientation per year, and we have to answer the question in seconds. So we just need to finish this calculation, that's all. So 3 zeros, we lose 3 zeros, and 100 will be there. Now this will become 100, and 18 into 6 divided by 100. So how much will that be? 18 into 6, this will be around 108. Alright, 108 into 6, so that would be around 650 sort of thing. And then when I divide it with 100, I think the closest answer would be 5 seconds. So by closest to, the question is saying that we have to find the closest value. So this calculation yields approximately 5, if I am correct. Let me just check it again. It's 108 into 6, so 648. So yeah, close to 6.5 is what we are getting. So 5 seconds would be a good choice. Alright, with this, let's move to the next question now. Again guys, this is one of the questions that wasn't discussed when we discussed the memory based paper. So this was a new question today. This is also a new question. This is more like a conceptual question. Alright, it is based on the Bernoulli equation, and it actually tells you how does a constriction in the artery leads to the blockage. Actually, this is that theory. So what happens, what actually happens is this only, that when these blockages were not there, the liquid or the blood that was flowing with a uniform speed throughout the artery. Alright, everything was fine, the pressure was same throughout, pressure was same at the same horizontal level. Alright, but due to these blockages, the area has reduced here. Like this area will be, let's say, A1, and this area will now become A2, with A2 less than A1. So that will lead to an increase in speed. We know from Bernoulli's theorem that not from Bernoulli's theorem, but from equation of continuity, we know that where area is less, the speed is more. So if the speed here is V1 and if the speed here is V2, so V2 will be more than V1 because the area is less at this constriction. Now because of this difference in speed, there will be a difference in pressure also. Like we write Bernoulli equation as P1 plus half rho V1 square is equals to P2 plus half rho V2 square. The term related to height has been omitted here because it's a horizontal tube, so both the points will have the same height, they will get cancelled out. So this actually tells us that where speed is higher, so this is larger number, so this pressure has got to be a smaller number as compared to P1, so that their sum can become equal. So the pressure here will be low. So what will it lead to? It will lead to a collapse of this region. Actually, this is what happens. Because the pressure in the constriction decreases, it further leads to a collapse of the artery, which actually further decreases the speed, and such a thing, such a phenomena actually leads to the blockage of the artery. So now let's read the options. It says as the platelets enters the constriction, the platelets get squeezed closer together, which seems fine, in the narrow region, and hence the fluid pressure must rise. So they have given a statement which seems correct, but they have considered that statement to be the argument in favor of the increase of pressure. So the pressure doesn't increase, so statement is incorrect. All right. B option says as the platelets enter the constriction, pressure is lower there. Incorrect. Pressure is lower there. So yes, this seems to be fine. Let's read C and D option to there. Let's read them also to be confirmed. So the artery's cross section area is smaller in constriction, and thus the pressure must be larger. Again, C option is also talking about a larger pressure at the constriction. So that is not correct. Pressure is same. Again, it is incorrect. So yes, B is indeed the correct answer. We have not only checked the correctness of B, we have also checked that the other three options A, C, D are incorrect. So that actually instills confidence in you while you are attempting the question in the exam, that there were 4 statements, you were asked to choose the correct one, you found out the correct one, and you also proved that, or you also confirmed that the remaining 3 options are incorrect. So that actually instills a lot of confidence in the answer. Now again, this question was discussed. This is the next question now. This was discussed in our previous discussion also. I'll just quickly tell you what happens here. It's a theory based question actually. It tells you, it is asking why do we see colors on which of the following is the result of diffraction. Actually we have to tell that which of the following phenomena is the result of diffraction. So guys, the colors that you see in a DVD or a CD, in CD or DVD, there are grooves like this, very close grooves are there, very fine grooves are there. So these act as large number of slits, all right, and they produce diffraction pattern or interference patterns. So we see those colors, the beautiful colors that we see on a compact disc is because of diffraction. All right. Again, this was something that we have previously solved. So actually that tells us how good our students were in providing us with the memory based questions. So thank you students, thank you so much. We enjoyed doing that discussion for you. So it says that, I'll repeat the solution. It says that 2 balls are projected with the same velocity with different angles. So there are 2 balls, we have projected them with same speed but at different angles. So we are aware that in such cases the 2 angles are complementary when the range is same, like one will land here, the other will probably land here. All right. So it says that if the angle of projection is for one of the cases 30 and its maximum height is there. So the lower angle is given to be 30 and the maximum height is given to be h. We want to find the other height. Let's call it as h prime. So I'm going to write h prime by h is equals to v naught square sine square 90 minus theta by 2g. That's the formula for height, divided by v naught square sine square theta by 2g, and theta is 30 degree here. So we lose everything apart from cos square 30 degree divided by sine square 30 degree. So cos square 30 is 3 by 4, sine square 30 is 1 by 4, so 3. So h prime will be equal to 3h. This is what we are going to get. All right, we did this question earlier also. Simple question. I am expecting many of you that you would have solved this question correctly in the exam also. Now this is an interesting question. This did not came to us when we discussed this paper previously. So this is an interesting question. It says that we are doing a simple experiment in which we are checking the stability of a bottle filled with different amount of shampoo in it. Okay. So this is a bottle. What we are doing is this, that let's say it was empty first. So we tilted this bottle until it became unstable. And when I say unstable, it means that we kept on pushing this bottle slowly. We kept on pushing it until it fell. Okay. So this is what we are doing, and then we are repeating the experiment. We filled the water, we filled the bottle with some amount of liquid, and then we repeated the experiment. Then we added some more liquid, then we again did the experiment again. So each time we are noting down the angle at which the bottle becomes unstable and it falls down. So we are noting down that angle in every repetition, and then we have to pick the graph that this height divided by the total height. We are calling this as F. So this ratio is F, and we want to make a graph of theta versus F, where theta is the angle at which the bottle becomes unstable and it falls down. All right. So looks like an interesting question. Looks like a very good situation actually to think about. So let's try to understand exactly when should a bottle topple. Okay, so let's say we are given a cylinder, and the center of mass of cylinder is somewhere here. Okay, now if I tilt this cylinder about this this edge, what happens is that this line starts tilting. All right, if I am tilting this, I am pushing the cylinder like this, the cylinder will tilt, and when this center of mass crosses this position, it comes to the right side of this point. All right, at that instant the cylinder will become unstable. Think about this. At that instant the cylinder will become unstable. So as of now the figure should be somewhat like this. See, so this was the center of mass. Okay, this was the center of mass earlier, and then this is the new position of the cylinder. When the center of mass crosses this height, then the cylinder topples. So we have to basically find out that what happens to this angle. Can we say that let me change the color once more, it is maybe too light. So can we say that this angle is the value of theta, like let's call this angle as alpha. I think it's not visible. So the center of mass was here. I'll make another figure. So cylinder is this, the center of mass was here. So join this with this corner, this angle, whatever it is, that is actually theta, because once you tilt this cylinder by an angle equal to alpha, then it will topple. So what we are calling as theta in these graphs or in this question is actually this angle. So we have to figure out how this angle changes as we fill water in the bottle. Okay, so let's try to understand this. I hope this much is clear, that ultimately what we are trying to figure out is, as we pour more and more water, what happens to this angle alpha. And what is this angle alpha exactly? We have joined the center of mass to this edge, and now this line, whatever angle this line makes with the vertical, that is that we are calling that angle as alpha. All right, so we want to figure out how alpha varies with the volume of water that we are pouring in. So think about this. This is an empty cylinder. Where will be the center of mass of this empty cylinder? You tell me, where will be the center of mass of this empty cylinder? Probably you are thinking, or you are typing, or you are saying it aloud, that it will be at a height of h by 2. All right, where h is this height. So for an empty cylinder, the center of mass will be at the midpoint of its axis, which is correct. Everything fine. Okay. Now think about a cylinder which is fully filled with water. Okay. Now think about a cylinder which is fully filled with water. Okay. Water or whatever liquid. I think it was some kind of shampoo. Okay. So if I now ask you, where is the center of mass of this system, are you still going to say it is at the midpoint of the axis? Think about this. Are you inclined? Are you feeling the urge to say this answer, to type this answer, to tell everyone that yes, I believe that this will be the center of mass of a fully filled cylinder? Because if that is happening, it's all right, guys, you are correct. Even now, the center of mass will be here only. Absolutely fine. So the center of mass was here. We start pouring in water. All right, we start filling it with some kind of liquid, may not be water. And once we are done filling it completely with the liquid, the center of mass is again at the same height. So in these two cases, if you ask me to compare the alpha angle, the angle that we marked as alpha, all right, what is your take on this? Like, which angle will be bigger or larger, alpha 1 or alpha 2, or are they going to be equal? What is your take on this, guys? Have a look at the two figure. I am presuming that majority of you are saying this. All right, again, I think majority of you are feeling the urge to claim this as the answer? If that is the case, you are again correct. Okay, this is all fine. So at least I have something to look at in the graph now. Like I should be looking at a graph in which the value corresponding to f equal to 0, the fraction, so the value corresponding to f equal to 0 should be same as the value corresponding to f equal to 1. Okay, that rules out this possibility, because here the graph is a monotonically decreasing graph. That cannot be correct. It rules out this also. It's a monotonically increasing graph. Cannot be correct. Alright, so between these two, one of the options is the answer. Alright, we are yet to figure out which one. So what can we do? Let's think of a situation which is in between these two. You know, somewhere here. So this was a totally empty cylinder. This is a fully filled cylinder. Think of the stage when the cylinder was half filled. When the cylinder was exactly half filled with the liquid. When this cylinder was exactly half filled with the liquid. Sorry, did not intend to. Okay, guys, just a minute. Yep. So this was the cylinder and I intended to show it as a half filled cylinder. So when it is half filled, okay, can we surely say that center of mass will lie in the lower half of the bottle, lower half? Because if I divide this cylinder into two halves, the upper half and the lower half, I see more mass in the lower half. Alright, so the center of mass is definitely, you know, somewhere below the midpoint of the axis. So, you know, if I have to compare this angle now, let's say center of mass is probably somewhere here. So if I say this angle as alpha 3, alright, so my previous angles were equal and these were alpha 1 and alpha 2, this position, angle measured from this position. Now we are measuring it from this. So what do you think? Is alpha 3 larger than alpha 1 and alpha 2? Well, I do think so, that alpha 3 is the larger angle. So alpha 3 is larger angle. So whatever angle we are starting and we are finishing at the same value. In between, the angle will go up, the angle will increase. Alright, so that rules out this option also. So this option is correct. Alright, so option D would be the correct here. So I guess it's a very nice question. Did not involve too much of mathematics, but involved a lot of you know, aptitude. You had to reason out, you had to provide logic for what you are thinking. So felt like a good question. Now again, this question is something that we received on the day of the examination also. This is the next question now, and we discussed this question. We found the answer to be 20 km. I remember that. So this question says that G at a height of 10 km, all right, is same as G at depth of how much? This is what the question is asking. So 10 km is very small as compared to the radius of the earth. So we can use this formula, Gs into 1 minus 2h by Re, and Gd will be written as Gh into 1 minus d by Re, where Re is the radius of the earth. So comparing these two, it is quite evident that 2h will be equal to d, and hence d will be equal to 20 kilometers. Alright, so that would be the answer. It's a simple question. Let's move to the next one now. This is a good question. Again, this is something that we did not receive on the day of the examination. So this question says that the following graph depicts the inverse of magnification versus the distance between the object and the lens data for a setup, the focal length of the lens. So you know, without you know, going into the details, first of all, let's try to figure out what kind of graph should we expect if we are trying to draw a graph between inverse of magnification and distance between the object and lens. So we have to make a graph between these two. So magnification for a lens is defined as V by U, alright, and we are also aware of lens formula, which is 1 by V minus 1 by U equal to 1 by F. When I rearrange terms in the lens formula, I obtain V as UF upon U plus F. Now this is something that you can verify. Simple rearrangement of this will give you UF upon U plus F. So this also means that V by U will give you F upon U plus F, which also means that 1 upon magnification will give you U plus F upon upon F. Alright, so this is what we have to keep on the y-axis, 1 upon magnification. So let me choose this as y coordinate, and U upon F plus 1, and this U is x coordinate in this graph. So we are getting the equation as y equal to x by f plus 1. Have a look at this. So we are getting the equation of a straight line. So that is a relieving thought, because we are given a straight line in the question, and now we have been asked to find out the focal length of the setup. So in this equation I can see that if I check the slope of the graph is 1 upon f. So if I find the slope using this data, then I'll be I'll get the focal length. So this length is given to be 250. Alright, this length is given to be 1. So slope is 250, and this is 1 upon f. This is given in meter. Alright, so this is 250 upon 1 meter. So we are getting focal length as 1 upon 250 in meters. Alright, so B option is what we are getting here when you finish the calculation. Alright, now a minor point here. See, from this graph, it appears as if the graph is passing through origin. Check this or not. Everyone, please check this. If I say that the graph is passing through origin, will you agree with me or will you disagree with me? Just have a look at this graph. It appears that the straight line is passing through origin. It's 0 here, it's 0 here. But the equation that I have written, it doesn't look like that it passes through origin. Have a look. It doesn't look like as it passes through origin. So is the question incorrect? Well, no, the question is not incorrect. Again, think deeper. This small length represents 50. Okay, this small length represents 50. So if I want to represent 1, see, if I put x equals to 0, I get y equal to 1. So if I have to represent 1 on this scale, I have to divide this small length into 50 part. One part will become 1. So if I try to do that, I was barely able to make 10 to 12 part. So I hope you are getting my point here. Though it appears as if the line is passing through the origin, but if we are given option of magnifying this graph, and zoom into this region, you will realize that this graph is actually not passing through the origin. It is just that we are viewing the graph from a very zoomed out view. Therefore, it appears to us that as if it's passing through origin. So no, nothing wrong in this question. I'm telling this because some of you may have this query that the question is incorrect and it should be a bonus question. I don't feel that way. All right. Okay. So let's move to the next question now. I hope you like this question. So this question says that in a circus, a performer, again guys, this is something that we solved that day. So it says a performer throws the apple. So guys, I explained this question in my previous video also. I'll not cover it in too much of detail today. I'll explain this. I'll tell you what to do here. So in these cases, when a particle is thrown towards a target, and at the same instant the target is dropped, in these cases what happens is that as this target falls down, this particle also, the projectile also loses height such that they always intersect. Like if this projectile was aimed for this target and the target was dropped at the very moment when this was shot, then they are bound to hit each other. Okay, so this is I covered this in detail in my previous video. So as of now, the time required to hit the target, I'll calculate the time by using the horizontal component of velocity. So are we aware of this angle theta? Well, I guess we are, because we are given the horizontal distance also, we are given the vertical distance also, so we can calculate tan theta. So let's first do that in fact. So tan theta will be 45 by 25, that is 9 by 5, and since we are aware of tan theta, it basically means that we can write sine theta also. We'll need that. So sine theta will be 9 divided by root of 9 square plus 5 square. So this is 9 divided by root of 106. Alright, similarly we can write cos theta also. Cos theta would be 5 divided by root of 106. So now time will be obtained by horizontal displacement divided by horizontal speed. So horizontal speed would be the V0 is given to be 24. So 24 cos theta. Cos theta is 5 into root of 106. So this is the time that we are getting. So it becomes 5 root of 106 by 24. This is the time. In this time, the distance fallen by this loop, vertical distance fallen will be half gt square. So it would be half into 10. Let's say the g is 10. The question doesn't say how much we should take for g. So t square will become 25 into 106 upon 24 into 24. So you finish this calculation, you will get the value of y. Then eventually what you have to do, you have to subtract this y from 45. So that will give you the final answer. Alright, you finish this calculation, subtract this value from 45, that will give you the final answer. I think it was probably either B or C. Like one of these values, this calculation will give us probably 22 and then the answer will be 23, or it may be the other way around also. You can finish the calculation and you can check it. I am not spending time on calculation right now. I can see that I am now falling short of time. So let me hurry a bit now. So again, this question was also provided by our students. We discussed this question again. I discussed this question in detail. I provided two kinds of solution, two solutions to this problem. One solution for students who haven't studied this chapter in 12th yet, and hence they are not aware of the concept of equivalent batteries. So what they need to do, I provided that solution. And if you are aware of the concept of equivalent battery, then this question is a cakewalk. Then this is a very easy question. Today I'll just repeat the method of equivalent batteries only. So what do we do in method of equivalent batteries? We change this entire circuit to one battery, all right, which we call as equivalent battery. So when I do that, I'll try to find the potential difference between these 2 points, assuming that this resistance is not present here. So if this resistance is not present here, then the only path at which current can move is this. And how much will this current be? This current will be 10 volts divided by total resistance, that is 600 ohms. So it will be 10 divided by 600. So this much current will flow. And then what will be the potential drop across this resistance? That will be current into 300. Alright, so the current would be 10 upon 600. So this is the current that is flowing into this circuit. Now what is the potential drop across this? So that will be I into R. R is 300. So it will become 5 volt. So this, whatever potential difference appears between these 2 points, assuming that this is not present, that becomes the equivalent EMF. Now we are yet to write the equivalent internal resistance of the battery. So to do that, we have to just ignore the battery signs and we have to find out the equivalent resistance between these 2 points. Again, assuming that this is absent. So if this would have been absent, these are the 2 points between which we want to find the equivalent resistance, or across which we want to find the equivalent resistance. So 300 and 300 connected parallelly to each other, parallelly. Okay. Now you don't have to pay the attention to how the current is flowing. Now the condition is you ignore this battery sign and then you try to find out the equivalent value across these 2 points. So these two are connected parallelly. So this will be 150 ohms. Alright, now you assume R to be present here. Now if R is present here, then the current in this circuit is 5 divided by 150 plus R, and this current multiplied by R will give us the potential drop across this resistance. So we have obtained the potential drop across the resistance in the first circuit. We are going to do a similar process for the second circuit. For second circuit, again assume this part to be absent. If this part is absent, current will flow only on this path. How much will this current be? This current will be 10 divided by 400. Now when this current flows through this resistance, the potential drop will be this much. So this turns out to be how much? It turns out to be 7.5 volt. So this 7.5 volt will become the equivalent EMF. Alright, and then we will have an equivalent resistance also. And to calculate that, again Ignore the battery sign, assume it to be a connecting wire. 100 and 300 are connected parallelly, so their equivalent value will be 100 into 300 divided by 400, so that's 75. So 75 plus 200, this 200 will be considered to be in series with this entire combination, so this is 275. And now you imagine this R to be present again. Alright, now the current in this circuit is 7.5 upon 275 plus R, and then you multiply it with R. So these are the two voltages that we have obtained, and the question says that these two are equal. So equate them and solve for R. It will be a simple calculation. Probably I think you'll get the value 100 ohm as the correct value. So this is how we can do this question. Alright, there's another solution provided by me. You can check my previous video on the essay paper discussion. So let's move to the next question now. Again, this question we discussed in the previous video also. A very simple question. It talks about the ratio of the gravitational force and the electrostatic force between two electrons, right? So gravitational force will be GME square by R square, and at the same time the electric force would be KE square by R square. R square will get cancelled, and therefore the separation between the two electrons has not been given to us in the question. So this G will be 6.67 into 10 raised to power minus 11, and ME is 9 into 10 raised to power. All these values are given in the question also, so you, even if you don't remember them, you are still fine. Alright, square divided by K. K is probably not given, but we know the value of K to be 9 into 10 raised to power 9, and then E square is 1.6 into 10 raised to power minus 19 square. So when you do this, you don't have to go for exact calculations. You see the options, they are the order of the options is quite different. Here we have a power of minus 24, minus 36, minus 44. So the order is quite different, so you don't have to go for exact calculation. Do some kind of approximate calculation that will give you the order. This will be your answer. Like once you finish this calculation, the order that you are going to get will have a power of 44 if you keep 2 digits here. Alright, if you keep it as 2.4, then the order will become 10 raised to power minus 43. Alright, let's move to the next question, guys. This was a good question. This was a good question because though it is intuitive, you know, I'm assuming that many of you may have selected option C purely on basis of intuition. It happens to be the correct option, but you know, you should always try to prove that also. So intuition is one thing. Yes, it is good in the exam if nothing comes to your mind, if you're not able to prove anything, but if you still have intuition that so and so thing should happen, you can decide to, you know, to take the risk or to avoid the risk. Here if you selected option C purely based on your gut feeling, you would have got the marks. But how can we prove this? How can we prove that this will not happen for any other value of theta? So guys, that can be proven like this. See, let's say this ray enters from at a general angle theta, and then it goes like this, then it somewhat goes like this, okay, then it goes like this, and then it goes like this and comes out. Okay, so this kind of figure may be possible. So in that case, this angle will be theta, okay, and if I draw a line here also, this angle will become 90 minus theta. I hope you can figure this out on your own. This angle will be theta, this angle will be 90 minus theta, and then again this angle will become 90 minus theta. So this angle will again become theta. Okay, this angle will again become theta, and again if I draw a line here, this angle will again become 90 minus theta. Alright, so this is the kind of figure that we are getting. Okay, now what we can do, guys, I'll be doing a little lengthy calculation. Just pay attention. So let's say this length is x, okay, and this length is L. Okay, so if this length is x, can we find this length? I think we can, because I'll directly write this length. Okay, if this is x, you know, this angle will be theta, so tan theta will be x by something. So this will become x cot theta. Have a look. This length will become x cot theta. This length, this angle is theta, so tan theta will give us x by x cot theta. So this length now becomes L minus x cot theta. All right, this length becomes L minus x cot theta. Correct. This angle is 90 minus theta. Now, just as we wrote this length using this and this angle, similarly, we are aware of this length, we are aware of this angle, we can write this length. So this length will become L minus x cot theta, L minus x cot theta into cot of this angle, so this will become tan theta. So this becomes L tan theta minus x. Alright, so we have now written this length also, and therefore we can write this length also. This length will become L minus L tan theta plus x. So I have subtracted this length from L. Okay, so I obtained this length now. Now again, this angle will be theta, this angle will be theta. So again, this length is known, this angle is known, so we can readily write this length. This will become this into cot theta. I am doing it directly now. So this we have got. So this length will become L minus of this value. Alright, let me write it as y for now because space is not there. So y will be L minus of this thing. Okay, so this is L cot theta. I am taking cot theta inside the bracket. Minus L and plus x cot theta. Have a look guys. Okay, so this will become what? This will become, I hope I have not committed any calculation mistake yet. Just hoping that. So it becomes L, in fact 2L minus L cot theta plus x cot theta. Alright, so till now we have written this length. Finally I am writing this length. So this angle is theta, so this angle is 90 minus theta. Okay, so this angle, this length we are aware this is 90 minus theta. Yeah, so again I'll multiply this length with cot theta, cot of 90 minus theta, so that will become tan theta. So if I multiply this with cot of 90 minus theta, okay, which is like y tan theta, then this length should be same as L minus x. We are writing this length now, so this should be same as L minus x. Let's do that and let's see what we are getting. Okay, so y tan theta will give us 2L tan theta minus L plus x is equals to L minus x. So this gives us what? I think probably I have committed some mistake or I subtracted this, so 2L this will have minus sign here, this will have minus sign from this step. Okay, so here also we will have a minus sign. So this minus x gets cancelled. You can see that we are getting tan theta as 1. 2L tan theta equal to 2L, so tan theta equal to 1. Therefore theta equal to 45 degrees. So yes, a little bit of lengthy proof. If you want to, like intuitively you could have answered, but again intuition can be wrong, can be right. So a good question I would say. Alright guys, so now we will begin part 2. Alright. Again, this question is something that I discussed in detail in my previous session also. I'll just briefly summarize here. So these planes will play the role of creating images. Like because of the presence of these conducting planes, some negative charge will be induced here, and the behavior will be as if a minus charge has been kept here, negative charge. Similarly, because of the presence of this plane, we can assume a negative charge is kept here, and a positive charge is kept here. So this is the equivalent arrangement that we can assume, like these planes will act as mirrors. All right, as far as their electric effect is concerned, they will behave to act as mirrors. So these are the three charges. Assuming them, we can say that whatever this charge was experiencing, that remains same. So for a detailed solution of this, like for detailed thought on what we are doing here, you can refer to my previous video. So as of now, there are three particles. This one is negative, this one is negative, this one is positive. There are three additional particles that we have assumed, and because of these particles, whatever is happening in this region, all right, in this part of universe, that remains same. Okay, so which basically means that whatever force this particle was experiencing in the original situation, the same force it will be experiencing now. So let's say this force is F, this force is F, attractive forces. Because of this plus Q, it will face a repulsive force which will be F dash, and we can write F and F dash, like F will be written as KQQ upon 2D square, and F dash will be written as KQQ upon 2 root 2D square. So this will become F by 2 actually. Check this. This will become F by 2. This value divided by 2. So the resultant of F and F will be in this direction, and it will be root 2F. So eventually the net force will be written as root 2F minus F prime. Alright, so substitute the values, you'll get the answer. Now we have written F prime, you put the values here, finish the calculation, you'll get the answer. The net force will be towards O, so these options are incorrect, and towards O, and this C option will be the correct one. Like once you finish the calculation, you will find that C option is the correct one, because I'm getting a root 2 minus something here. So once you finish the calculation, you will realize that this minus sign appears. Alright guys, now this is something that we did not discuss in the previous discussion. Students sent me some kind of snips stating this kind of question, but I could not comprehend completely, like the information provided was not complete. Now I can see the complete question, and I can understand what is happening. So there are two fixed structures here. Okay, one structure is this and the other structure is this. So these are fixed. So this one is elevated, this one is elevated, this is above this structure. So once we release this C ball, it takes some time to fall down. So it takes some time to fall down from a height h, the time taken for free fall. So in fact, if we want to write, we can write half g tc square. So tc will be known to us, 2h by g root of this. Though we don't need to calculate this, I'm just telling you. Now once we release this ball will travel here, it will acquire some kind of speed, let's say v1, but the vertical velocity is 0. The vertical velocity is 0 when this ball gets detached from the structure, and this is where we start the stopwatch to calculate TA. This TA, we start the stopwatch at this instant. So when we started the stopwatch, this ball did not have any vertical velocity, and it was horizontally thrown from height h. So we expect this ball to travel like this. All right. So can I say that the time taken by ball A to finish its journey beyond this point will be same as the time taken by C, because A has fallen through the same height with 0 vertical velocity initially. The same happened with C. C also fell with through the same height with 0 vertical velocity. So they will, like, this is a common situation, you know. I'm pretty sure that you would have seen videos and animations which tell you that if a ball is thrown horizontally and simultaneously another ball is dropped, okay, let's drop it from behind so that it doesn't, so they fall same height in same time. Like when this ball will be here, this ball would have reached here. When this ball is here, this ball would have reached here. So we can prove this mathematically also, but mathematics doesn't help us to remember the concept. Such figures do. So they hit the ground together. Like if one was thrown horizontally, another was released. Since their vertical velocities were same and they are traveling through the same height, they will take the same time. So TA will be same as TC. Alright. Now the interesting thing is, when we release B, B will travel here and it will also separate from this structure with the same horizontal speed as A. I hope you agree with this. Since these structures are identical, when B is released, B will separate from this structure with the same speed as V1. Now the time taken by B to reach X, TB, okay, can I say that this is the same time taken by this ball to travel the same horizontal distance? Because A ball has traveled the same horizontal distance with the same horizontal speed in TA time. Therefore, B will also travel the same horizontal distance with the same speed in the same time, and therefore we can claim that TA is equals to TB is equals to TC. Now there is only one option that indicates both the equalities, though it's a misprinted option. It should have TA equal to TB equal to TC. Here 2 times are given as TC, but I guess since there is no other option containing two equalities, we are fine with we can safely click on B option. That will be the correct one. All right. Right. I hope you like this question. Let's move to the next one. Now guys, this is again a good question. It involves your understanding of optics. So what we have to do in this question, I'll tell you probably on a blank slide. Let's go back. This was pretty much blank only. So I'm solving the next question, but I'm using the blank space here. So the results that you should be aware are this. Like to solve the next question, the results that you need to be aware of are let's say this is a converging lens or a convex lens. So if we are getting a real image, which we are because we are obtaining the screen, the images on the screen, so the image has got to be a real one. So this lens inverts the images. When the object is real and when the image is also real, then the image is inverted. And when I say inverted, of course this kind of inversion you are aware. What you may not have thought about is this. Let's say we had another arrow coming out of the board, coming out of this plane, then its image will appear like this, going into the board. So even this kind of inversion takes place. All right. So if we have an object which is sticking out of the board, then this lens will create an image which will go into the board. Okay. So this is one aspect that will be used to solve the next question. The another aspect is, as we move closer to the lens, all right, the image also travels in the same direction. Like in whichever direction you move the object, the image also travels in the same direction. So if we are moving it closer, the image will go farther, like it will travel in the same direction. That is the concept actually. And it will also grow in size, because in the present scenario it is moving farther and farther away from the lens. So magnification is increasing, V is increasing, U is decreasing. All right. So with these 2 points, we can safely address the next question. Like we have to decide both kinds of both the rules that I told you. We have to use them to arrive at a conclusion. So let me go to the question now. All right. So here we have, like, the side view of this figure would be somewhat like this. The side view of this figure would be somewhat like this. This is the lens. Okay. This RG is above the principal axis, so here they lie. Like if we are looking from this plane, this RG will appear as a straight line to us. Like we are looking somewhere from here, so RG will appear to be a straight line above the principal axis. I'll write R first and G after that to indicate that R comes first when we are looking from this side. And these 2 balls, they are below the principal axis. White is closer to us, followed by blue, or whatever the color is, blue, black, whatever it is given. Okay, so now what you can say to address this question, you can imagine one object here. So the image will be formed somewhere here, it will be inverted like this, and the other object here, the image will be inverted like this. Okay, so this RG arrow will appear like this. This WB will appear like this. Also, since R was closer and G was farther away from us in this figure, so here G will come first and R will go back. Same thing will happen here. B, W. B will come first and W. So among the options that we have, A option shows us green first, then red below the principal axis, and here blue first, white behind blue above the principal axis. So A option is the correct one. Alright, in all other combinations something will get violated. So this is what will happen. Okay, again good question, I would say. Regarding this question, guys, I solved this question. My answer was not matching. I was getting n equal to 11. I probably some calculation mistake can be there, but I checked it several times. I was still getting n equal to 11. I don't find 11 in any of the option, and even if I go for the closest option, which is 10, the given answer is still different. It is 6. I'll tell you what the method is. Okay, let's see if there are any changes in key, or maybe I'll do it one more time. Maybe I'll be able to do the correct calculation this time. So I'll tell you what to do, what the question says. So as of now, there are 9 coins here. Okay, the container's mass is given to be negligible, which is an important piece of information. Massless plastic container of height 9 centimeter. So whatever weight is there, it is because of these coins only. Alright, so 9 times the weight of the coin. Let's assume the one coin has got a mass m. So 9 times the weight of the coin is equal to the buoyant force which is acting right now. So right now, according to the question, 3 centimeter is inside the water. Alright, so 3 centimeter into cross-sectional area. This is the volume that is submerged. Okay, then density and G. So this is one of the equations. 9 mg is equals to buoyant force. I need not take care of the units here, like I need not convert 3 into meter or area into meter square, because I'm planning to take some ratios, so they will get cancelled out eventually. Like even if we have a constant factor here containing some powers of 10, that won't affect anything. You will see that in calculation just now. So as of now, this is the condition. Now the question says, if we start putting more of such coins on its lid. So this is important to understand, that we are putting the coins here. Okay, it is observed that after n coins are put, its equilibrium changes from the stable to unstable. The equilibrium is floating, is stable with the. So they told you in the question, you are given a hint, you are given a condition that when is the equilibrium considered to be stable. Equilibrium is stable if the geometric center of the submerged portion is above the center of mass of the object. So when this switch will happen from stable to unstable, these 2 points, the geometric center of the submerged portion and the center of mass of the object, they will be at the same location when the switch happens. Okay, so let's draw final figure. In final figure, we can expect some n coins here, and this height to be unknown to us. Let's call it as h, because I'm expecting that when I put more coins, the container will further go down in the liquid. So this will no longer remain as 3 centimeter, it will change. Okay, so now what I'm going to write, 9 plus n mg. So this is the total weight that buoyant force is supporting now. Alright, now the buoyant force will be written as h into A. So this is the volume submerged now, into rho into G. Alright, so this is my second equation, and again as I told you, I'm planning to take some ratio. So even if some powers of 10 was present here, after taking the ratio they will be lost. So when we take the ratio, let's divide the second equation by the first one. So we'll be getting 9 plus n divided by 9 is equals to h by 3. A rho G will get cancelled. So this is an equation that I'm going to make use of. Right, let's just try to learn this equation, because I may have to rub this to do further calculation. So 9 plus n by 9 is equals to h by 3. So this is one equation that we got. Now we have to solve based on the last line of the question, which says that geometric center of the submerged portion. So geometric center of the submerged portion is at a height of h by 2 from the base of the container. This is the base of the container. From here it is at a height of h by 2. Alright, so now let's try to figure out where will the center of mass lie. The center of mass of this 9 plus n coins, we will measure the distance of center of mass from this line only. So this mass is how much? It is n into mg. So this mass divided by total mass. Total mass is 9 plus n mg. All right, this mass divided by total mass into the separation between the two. Okay, yes, just a minute guys. Into the separation between the two, which is 9. Yes, so this becomes this distance, like the distance of center of mass from the base, and we want this to be equal to h by 2. So this is the equation that we need to solve. We will cancel mg here, okay, and by picking out the value of h from this equation into this equation, we'll get the solution. I was getting n equal to 11. Should we finish it one more? Let's try to just confirm. Like if I put this 3, we can cancel it. So h becomes 9 plus n by 3. So 9n upon n plus 9 is equals to h by 2. H by 2 will become 9 plus n by 3 into 2. So it becomes 6 9. Sorry. This is 6 into 9 is 54. So 54n is equals to 9 plus n square. Let's try to solve this once. Let's hope this time I get the correct answer. So if I expand this, it becomes 81, or rather I can just check after putting n equal to 11. So this is around 540, around 600, and this is what, 20. If I put one of the given options as I may have committed a mistake or what, let me just check. Uh, 11, 540, 600, 20. Nope. Let's try to figure out the answer only. 54n equal to 81 plus n square, and then 18n. So this becomes 36n equal to 81 plus n square. Alright, so n square minus 36n minus 81. Sorry, plus 81 equal to 0. So we'll have to solve this equation. So guys, solving this equation will get the answer. My answer was not matching to, you can just try. I've told you the concept. You have to write the force balance equation twice. One, for the first time, the mass of 9 coins will be balanced due to the buoyant force. Then you will write the mass of 9 plus n coins will be balanced due to the buoyant force. That will give you a relationship between n and h, where h is the new submerged length of the container. And then you have to use this condition that the geometric center of the submerged portion will be at the center of mass of the this entire system. So that will give you the result. All right, hopefully this will give you the result. Okay guys, now this question, okay, this is a very calculation based question, good question. Small coin is fixed at the center of base, so there is an object somewhere here. There is an object somewhere here, okay, somewhere here, and we are looking from here, okay. So using the dimensions given, as of now this object will not be visible. Like without any water the object will not be visible, because the situation is somewhat like this. I'll draw the figure here. The situation is somewhat like this. Like the observer is somewhere here, okay. So the straight line, the line of sight of the observer cannot reach this point, okay. But when enough water will be filled, then the figure can become like this. Then the ray from this coin can reach the observer's eyes, okay. So the data is given to us. We have been told that this height is 4 meter, okay. We have been told this height is 4 meter. This height is 5.75, I think. Yes, this is 5.75. So this basically means that we are aware of this height also. So 5.75 minus 4 is 1.75 meter, and we are aware of this distance also. This is 0.5 because the radius is given to be 1 and this distance is given to be 1.5 somewhere, yeah, this 1.5, and the radius is given as 1. So this distance would be 0.5. So basically we have been told this angle now. This is 0.5. So the light is coming from here. If I draw a normal, okay, the normal will be drawn like this. Let's say this is angle of or you can say angle of refraction. Okay, this is angle of refraction. So even this angle will be r. So tan r is something that we can readily calculate. Tan r is 0.5 divided by 1.75. So this will be 1 upon 3.5. So this will be close to like 0.27 kind of. All right. So this is quite small. We can consider this tan r as sine r also. So this is 0.27. And similarly, we have to find out this sine of angle of incidence. All right. So let this distance be x. Let this height be y. So tan I can be written as x by y. If I want to write tan I, it can be written as x by y, and tan I can also be written as sine r divided by mu. Okay, so like tan I can be approximated as sine I again, and sine I can be written as sine r. Sine r is 0.27 divided by mu, which is 4 by 3. So this is one relationship that we will get between x and y. This is one relationship. Okay, you can get another relationship between, we need one more relationship between x and y to solve this question. And to do that, just a minute, this angle is I, we have obtained tan I as x by y. What else we can do? Yeah, we can also write x as like this distance is x. Okay, this distance is x, we are assuming it to be x. So yeah, this angle is r, even this angle will be r. So we can write one more thing for tan r. We like tan r can also be written as this length, which is 1 minus x divided by this length, which will be 4 minus y, and tan r is already known to us. Tan r is approximately 0.27. so this is one equation, this is another equation. Solving these two equations, we will get the value of x and y. All right, we are specifically interested in the value of y. I think we need this height, because after getting this height, okay, after getting this height, what you have to do, y into area will become the volume, and the volume flow rate is given to us here. Okay, 0.1 meter cube per second. So this into time, this will give you the time. Okay, so yes, a bit complicated question, mathematically involved question. It would take about 4 to 5 minutes to finish this question. So yes, then guys, you cannot expect anything less from KVPY also. KVPY is indeed a good examination. So guys, the correct answer that we will get after finishing all the calculation will be 63 seconds. And that's all, I guess. That should be the last question. Yes. So guys, that summarizes the paper, KVPY paper for you. I hope you enjoyed these solutions. Some of the solutions I did not take too much into detail. That's because I've covered them in detail in my previous video. So if you do want to have a look at those detailed solutions, you can go to that video. With that guys, I'll end this session. The other subjects will just, they are lined up. They will happen just now. So guys, bye-bye. Take care. And like the video if you enjoyed watching this. Share it with your friends and subscribe the channel guys. So that's it. That's all from my side. Bye-bye guys. Thank you so much.